All right, welcome back, everybody. My name is Nick. This is Swiftful Thinking, and as promised, in the last video we talked about object-oriented programming. One of those objects that we talked about was a struct. Structs are value types. They are stored in a stack. And in this video, we're going to do a deep dive on how we can actually work with structs. So we're going to create them, and then we're going to mutate them. Mutate is a scary word if you've never written code before, but it's really not that complicated. It just means updating the object. It's a special keyword that we use when we're talking about value types, or more specifically talking about structs. So basically we're going to create a bunch of objects, and then we're going to learn how we can update the data in those objects. As we go through this, we're going to do a bunch of examples. I'm going to point out which of those examples are beginner friendly or not. I think it's important to learn both. But if you were just learning to code, I would suggest sticking with the beginner-friendly options because it will probably save you a lot of debugging in the future. Again, in this video, we're learning just about structs, and in the next couple of videos, we're going to learn about some other types, such as enums and classes.
In the last video, we looked at object-oriented programming, and that was a difficult video. Trust me, I know that it was hard. Do not feel overwhelmed, though. It's going to get easier. We just need to address some of this stuff up front so that we are not just writing code and totally confused the whole time. I promise you it'll get easier. And in this video, we're going to dive into structs. So in the last video, I talked a little bit about the differences between a struct and a class. But I think the only way to really learn it is to actually just start making structs and classes and playing around with them a little bit. So I'm going to right click the navigator, create a new file, a new playground page, and let's call this one structs. And in here, let's write some code. And so again, if you were not with me in the last video, just to point out some of the highlights of structs. Structs are fast. They are super, super fast. We love using structs in Swift. Structs are stored in the stack. That's where they're stored in memory. And objects in the stack are value types. So structs are therefore value types because they're in the stack. All right. And then value types are copied, and we're going to say mutated. Now, mutated is a word that we have not covered yet, but I'm going to explain it in this video. So last video, I was saying that structs are, you can copy and paste them, basically. That's an easy layman's term way of thinking about it. But really what we're doing when we were editing a struct is not copying and pasting, but mutating the struct. I'm going to talk a little bit about that in this video. So let's actually get started writing our first struct. So I'm going to create a struct, and I'm going to call this quiz. Just a follow-up from the example in the last video. And we'll say maybe every quiz has a title. So we'll say let title of type string. And maybe every quiz has a date created value that is of type date. A lot of times if you're going to store something in your backend, you also want to store like the date created so that you have a reference to when this object was created. So you'll start to see this more and more in production apps. Now, so far in this course, we've been using basic types. So we could say let my object of type string and set it equal to a string. Hello. But now I could say let my quiz of type quiz, and I could set it equal to a quiz. Now, when I go to create a quiz, we can see this, what's called the initializer here. So this completion is showing us the initializer for the quiz. And so what this is telling us is that in order to create a quiz, we need to give it a title and a date created. All right. And so this is no different than like calling any other function that we've been building out in this entire playlist, right? This is just a function, and these are the two parameters. So the title, I will say maybe quiz1, and the date created, I will put maybe today's date. Another way to write today's date is just now. All right, so now in my code, maybe I access my quiz.title, and I can print that out. I'll run this code here. All right, so that obviously worked, but the first question is, where did this closure come from? Because we didn't make a function that said pass in a title and pass in a date created. And that's because structs have what's called an implicit init. I'm going to put a comment here, structs have an implicit init. And that just means that the compiler is generating this init for us. But really what this is a function that is the initializer for this object. And so if I wanted to manually write that out, I could create an init, open and close the parentheses and open the brackets. And then in this function, this init function, I can pass in a title and I can pass in a date created. And in order to create this object, I'm going to call this init. And then with what's passed in, I'm going to set up this object. So I'm going to set the value for this, and I'm going to set the value for this. So this I will refer to as self.title. So self meaning this title and not this title. I will set this title equal to the title that we are passing in. And I will set self.date created equal to the date created that we are passing in. All right, so this initializer here, so this piece of code is the same thing as this piece of code. It was just that Swift automatically generated this for us without actually writing the code. And that's just like a convenience thing that we have in Swift, so that if we created this quiz and we were going to use this initializer, we wouldn't actually need it in our code. We could just do it like this and this would still work. Of course, we can always write these out manually ourselves if we really want to. So the next question would then be, why would we ever create our own init? And that's because we can customize the init if we create our own. So for example, I'm going to copy this and I'm going to paste another one here, and let's comment out the first. And maybe every time we create a quiz, we want to pass in the title, but if we don't pass in the date created, maybe we want to give that date created a default value. And so I probably should have covered this in the functions video, but let's cover it now. So let's do a default value for date, right? So right now, if I create a quiz, I have to pass in a date. But I want to make this so that if I create a quiz, I don't have to pass in a date, and the default value will be .now. So what I can do is actually in this function parameter here, I can give it a default value by setting it equal to now. So now I have the exact same init, but there's a default value here. And the reason I would do that is because if I now call let my quiz of type quiz equals quiz, I can see that date created is now like a little grayed out. And that's because I don't actually need to pass one in. If I don't pass one in, it will default to the default value. So here, if I put in quiz 1, I now don't need to add date created when I actually initialize this object. All right, we're going to do one more quick example. So maybe inside this quiz, there's actually another, maybe a Boolean called maybe it's premium. Maybe it's a premium quiz that only premium users can access or something like that. Let's make it a Boolean and let's make it optional. I want to show you guys that we can actually use optionals inside these structs as well. So I'm going to copy this and paste another init that we're going to make a third init here. But this one, we're going to try to customize it even more. So maybe I'll create another, maybe a pass in a value for is premium. And we only need an optional Boolean. So I can also make this an optional Boolean and set self.isPremium equal to is premium. And this works as well. So if I create a quiz, I can say let my quiz equals quiz. And I can see when I create a quiz, the date created is still grayed out because I don't need to inject one. If I want to, if I hold the option button and click enter, I can now enter a custom date if I want. But if I don't hold the option button and I just click enter, I now don't have to add in a date. So I can put here quiz 1, and then is premium is a Boolean. So I could put true, I can put false, I can put nil, doesn't really matter. It understands that this is going to be an optional value. All right, one final thing I want to touch on these inits is that maybe instead of having a default value for date created, I want the developer to actually pass in a date, but I'll let them put maybe an optional value of nil for date. So maybe we want to be able to pass in a nil value, but when we actually create the object, we don't want it to be a nil value. So for example, I can make date optional here. And so now when I go to create my quiz of type quiz, you'll notice that date created is required, and I can put in quiz 1, and I'll put in is premium of maybe false. But date created is an optional date. And so we pass in an optional date, and then we try to set a non-optional date equal to the optional date. And this is yelling at us that we have to unwrap our date. And so this is one case where we can start using our ability to unwrap optionals. So we can use an if let, or we can use like a nil coalescing here. So I'm going to say here, date created in this quiz is going to either be the version that we pass in, otherwise .now. This will then make sure that we always pass in some value, but if I pass in nil, it will default to now. All right, maybe this is not a perfect use case, but there are use cases where you're going to want to do something like this, or something like this, or something like this. As you start building more structs, you can start to customize how you want your code to look and feel. All right, let's move on down here to another example. I'm going to put just some comments here, and what I want to do now is actually start trying to edit this quiz. Because as I mentioned in the last video, quizzes are value types, meaning that when we edit them, we're actually basically like copying and pasting them, or really what we're doing is mutating. So let's learn how to mutate a struct. All right, so down here, I'm going to create another struct, and I'm going to call this maybe user model and open the brackets. So you're going to see me do this a bunch in the next couple courses. When we create objects, I often call, if it's a data model, I will include the word model at the end of it. So a user model is a data model for a user. I can just call this user, and I think most production apps would probably just keep this as like a user because it's easy to write. You don't need the word model. But I think when you're learning, it is a nice clear indicator that this is my data model. So I'm going to call this user model, and then maybe every user has a name of type string, and every user maybe has a value for whether or not they are premium of type bool. All right, now this struct only has lets in here. There are no vars, right? If you don't know the difference between a var and a let, go watch the earlier videos in this playlist, because I have to assume that you know the difference between that at this point. So when you have a struct that only has lets, this is what we refer to as an immutable struct, which really means that it has all let constants, which really means immutable means not mutable, which really means that we cannot mutate it. All right, so we haven't learned how to mutate it yet, but an immutable struct is a coding practice that I do use in most of my apps. Some people will tell you that you should use it all the time. Some people will tell you that you don't need to use it. But immutable struct basically means that these are all constants. And so the benefit here is that as the developer, if we take this user model and we pass it around our app, right? Maybe there's 100 different files that it touches. Because these are constants, we know that the data is never changing. And so that's the benefit of having something that being immutable. You know that no matter where it is in your code, it's always going to have those values. Those values are never going to change, like in the middle of the function, in the middle of some process. It'll always have the exact values. And there's a lot of benefits to that when you start writing more complex apps. So if I go to create this user, I would create a var. Let's call this user 1 of type user model. And I'll set it equal to a user model, and I need to pass in a name and an is premium. I'll do Nick, and I'll do is premium as false. All right, so now later in my code, maybe I'll have a function that says maybe mark user as premium, okay? And in order to mark the user as premium, I want to basically take the user as is, this current user model, so with the same name, and just change the value of is premium from false to true. All right, now we know that this is a constant, so we cannot just edit this value. What we're going to do is create a second struct with the same data, but change this piece of data. All right, so how we're going to do that, let's first print out here user1, and let's actually just call this mark user as premium. If I run this code real quick, we can see that user1 prints out, and is Nick, is premium, is false. All right, now what I'm going to do is set this variable of user1 equal to a new user model. And when I create this user model, I could type in Nick again, right? But I really want to just take the current value from this object and then use that. So I'm going to pass in user1.name, so the value from the current object, and I'm going to change is premium. Instead of false, I'm going to make it true. And now here I will print out user1 again. So if I run my code now, we can see that the first time it's false and the second time it is true. So what we did here was we created a user model, and then in order to change one value in it, we created a brand new user model using all of the existing data, but changing this piece of data. All right, I hope that makes sense. So this might feel a little counterintuitive, right? Like we already have this object. Why would we create a second object and then change the value of it rather than just changing this object as is? And that's because these are value types. When you change a value type, you are mutating or basically creating a new version of that value type. Now, this is a very manual way to do it and not how we would actually do it in code. So how do we make this a little bit better? Let's comment this out, and I'm going to create put another line break in here. And let's create another struct, and I'm going to call this user model 2. So just another version of user model. This time we're going to have a name of type string, and this time we're going to have a var of is premium of type bool. All right, so same thing as this, except this one has a var. So this one is no longer an immutable struct. This is a mutable struct. So now I'm just going to put mutable struct, which means that we can mutate it. And so when we change this var here, we're actually going to mutate the struct. So down here, let's create a var user2, set it equal to user model 2. I'll say Nick is premium is false. And let's create a function, mark user as premium 2. Let's do the same thing where we print out user2. And let's print it out again after the end of the function. And we're going to update user2, but this time, instead of setting it equal to a new version, we're just going to access this value and change it. So here we're going to say user2 dot is premium equals, let's set it to true. And let's call mark user is premium 2. Let's run this code. And you notice that again, it is false and now it is true. And this looks a little counterintuitive. This looks like this is very different from this, but in reality, it is not. So let's break this down here. User2 is actually a variable itself, meaning we can actually change the object of user2, right? So here we had one object, one user model, and then we changed this by creating a new user model and setting it equal to the new one. Here, it looks like we just edited the existing one, but really what we did was mutate the existing one and set it equal to the new mutated version. So I can prove that because here, if I made this a constant and I try to just update user2, we can see that we're going to get an error from the compiler. Because when we're actually calling user2.isPremium and we're editing this, it's really mutating the struct behind the scenes. So really, it's changing this object from the current model to a new version of the model. And that's super confusing because this is all happening like behind the scenes and we can't really tell, and it's hard to tell that this has happened. So here, this is going to mutate the struct. And at least for beginner level purposes, mutating the struct is the same thing as this. And now this is a step in the right direction, but I want to take this one step even further. So I'm going to copy this blind break, come down here, and we're going to do one more version. All right, we're going to do another struct and call this one user model 3 and open the bracket. And user model 3, we're going to revert back to being an immutable struct. All right, so if we know an immutable struct means everything must be let. So I'm going to copy those and paste them down here. We have another immutable struct. But this time I want to actually be able to edit the value for isPremium, even though this is immutable. And so up here, we had some code for here. Here we have a function that creates a new user model and returns it back. And I'm basically going to just take this function and move it into the struct. So inside the struct now, I'm going to create a function called markUserAsPremium. And this function will return a user model 3, same way we were doing it above. But this time we will return user model 3, but we're doing it from inside the struct already. So up here we had to access user 1 and then access the name. But now we are already inside the struct itself. So we can just access the name directly. And then we'll set isPremium to true. Or we could even pass in a value here. This is just a function. So we can say new value of bool and pass in the new value. All right. So now in my code, I can have var, maybe user 3 of type user model 3. And I set it equal to a user model 3 with Nick isPremium true. And now I can call user model 3 and set it equal to user 3 dot mark user as premium. And I'll pass in a new value of maybe true. We should start false and then we move it to true. All right, so this works just the same. Again, in Swift, if we're just returning out of a function, we don't need that return keyword. This works the same way as this. The only difference is that the function markUserAsPremium is within the struct itself. So here there's nothing inside the struct. Here it is within the struct. This is a better coding practice because now the struct is in charge of changing its own data. So we know that anytime that this struct is going to change, it's going to come from inside the struct itself. Now again, we are going to create another struct here and then return that struct. So that's why we are setting user3 equal to the returned new struct from this function. We're going to create one final version here. And this will be another mutable. We'll call this a mutable struct. And this will be struct, you called it user model 4, open brackets. And again, we're going to use our mutable one. So name is a constant and isPremium is a variable. But again, last time we did this, we had a function that was not in the struct and we called user2.isPremium is true. We want to now move this mutation inside the struct itself. So we're going to come down here and we're going to create another func called markUserAsPremium. All right, and maybe I'll pass in a new value of type bool. And what we're going to do is just change the value locally isPremium equal to the new value. Or sorry, markUserAsPremium is not a good description if we're going to pass in a new value. So we should either do markUserAsPremium, where we set isPremium to true, or we could do something like update isPremium value to a new value of bool, where we pass in a new value. Either of these are fine. We just want to be explicit that if we say mark isPremium, it should always be going to the premium state. But one thing that we're going to have here is the compiler is going to yell at us that we're trying to mutate this object, but self is immutable. So even though this is a variable and we technically can change it, this code now is within itself. So if you think back to earlier in the last video, I was talking about how when we mutate an object, we're actually like copying and pasting a new version, right? So the problem with is happening now, the compiler is saying that when we go to change this variable, we're actually going to be creating a new version of this struct. We're going to mutate the struct. But the problem is that if we are running a function inside this struct, something might break because this struct itself is going to change. The actual object that we are inside is getting mutated. So this is going to cause problems in our code, right? So if you're calling a function inside of a struct, but that struct, that object is actually changing, then you have a problem because the function is a child of the struct. And so the way to get around this in Swift is to mark the function as mutating. So if I click the fix here, this tells the compiler that this function is actually going to mutate the struct itself. And now we can do this. So here I will put mutating as well. So again, this is the Swift compiler helping us out, telling us that we're trying to mutate this struct here. And in order to do that, we need to make sure that we mark it as mutating. The benefit of this user model 4 versus user model 2 is that here we're updating the value of isPremium from outside of the struct. Again, we can do this from anywhere in our code, but that can get really messy because now you have all these places in your app that might be editing the value of user model 2. Whereas in the user model 4, the only time that this is ever going to get updated is from within the user model itself. And since we're only updating it from within the user model itself, we can actually make this a private set var. I'm going to do a video in the future on what private and private set means. But what this means right now is that we can only set the value of isPremium from inside of here. So if we had a var user4 and set it equal to user model 4, so Nick isPremium false. All right, so I can call user4 dot mark user as premium. I can call user4 dot update user as premium as true, but I cannot call user4 dot isPremium equals true. So the way we did it in user2, I can no longer do because the setter is private to inside the struct. So I can access the value, so I can get the value. So I can set let new value equal to user4 dot isPremium. I can get the value, but I cannot set the value from outside of the struct. All right, that was a lot to take in. Structs are definitely a little tricky to work with, but you should know how to mutate a struct. I will say that in most of the videos that if you're going to follow my channel, most of the videos in my beginner courses, I'm actually doing this version. So I like to keep an immutable struct. And then when I go to edit it, I'm just going to create a new version of the struct with the same data and then just update whatever data I'm changing. This is how I was taught when I was learning to code. This is probably the best way for beginners to do it because it's very explicit. You know that this is just a function that is returning a new version of this struct. So even if you're confused about how mutating works, you know that when you run this function, you're just going to get back a new updated data model. And so when working with like beginner level apps, I find that this solves a lot of frustrations and confusions around mutating. However, in a more advanced app, I probably would shift towards something much more like this, where we're actually mutating. And that's because there are slight technical benefits to mutating a struct rather than creating a totally brand new one. Those benefits are not worth it to confuse you when you're just learning to code. But once you get really good at doing this, then maybe start shifting your code to something more like this. Now you guys know how to use structs, and we can put as many pieces of data inside these structs as we want, and then pass them around our app. So this is a great alternative basically to using tuples. So before two videos back, I showed you guys how we could make a tuple where we had maybe a name and isPremium and isNew. Now we can create a single struct that has all of this data. So we can create a struct user5 that has a name, that has an isPremium, and what was the third one? and is new, and so on and so forth. And we can keep adding as much data as we want into this struct. And now when we pass it around our app, we just pass in a user5. We don't need this big long tuple that's going to get super confusing. Thank you guys for watching. As always, I'm Nick. This is Swiftful Thinking. You are on your way to becoming an expert iOS developer. And if you are ready, I will see you in the next video.